we had seen about a supernode analysis. The supernode analysis only consists of your independent sources. Now we are going to go for your dependent sources. So in a circuit, if it consists of dependent sources, how we are going to do it? So now we are going to say this circuit, it consists of your dependent sources here. So here we have two supernodes. So between two nodes, I am going to have your V1. This is your one supernode here, and this is going to be your another supernode. So here in this case, this is going to be your third supernode there. So what we are going to do is, here anyway this is going to be a ground potential, so we cannot remove it, so we'll be having it here. So first is mark all the nodes. So when I'm going to mark it, we are going to have V1, this is your V1 voltage, V2, V3 and V4. So here, as I said earlier, wherever resistance is there, mark the currents. So here in this case, your V4, I'm going to assume this current to be your I4 current, this current to be your I3, here it is your I2, here already I1 it is given in the circuit, so we are taking from I2, I5. The current direction, however you want, you can take it arbitrarily there. So now first I'm going to see here between two nodes, these four nodes I have, and the center node I'm going to take it as a reference node there. Now what we'll be doing is, we'll be taking your this one supernode. So supernode is V1 minus 2 pluses plus E1 minus your V5. So I can assume that this is going to be your V5, that is anyway 0. So V1 minus plus E1 is equal to 0 there. So V1 is equal to minus E1. Next, coming to your node V2. So node V2, incoming current is I1, outgoing currents are going to be I2 plus I5. So I5 is equal to V2. The current here is going to be your minus V1 divided by R1. Next is I2. I2 is nothing but V2. Current is going from V2 to V3. So V2 minus V3 divided by R2. Next, for a supernode between your 3 and 4. So this is going to be the next supernode. So when I'm going to start from here, this is your incoming current to this supernode is going to be your, so here in this case V4 plus 0.5 VI minus 2 pluses plus 0.5 Vy minus V3 is equal to 0. So 0.5 Vy is equal to V3 minus V4. What is Vy? Vy is nothing but the voltage that is going to exist between V1 and V4. So if I write my KVL equation here, it is going to be V1. So minus 2 plus is going to be plus Vy minus V4 is equal to 0. So Vy is equal to V4 minus V1. So we substitute V5 is equal to 0.5 into V4 minus V1 is equal to V3 minus V4. Next is, this is your supernode here, 3 and 4. So now we are going to see how many branches are going to be connected. So 1, 2, here in this case, these two are also connected, 3, 4. So totally 4 branches are connected. So we are going to see what are the currents that are going to come here. So the currents is going to be 0.2 Vx incoming current, I2 is going to be the incoming current, so I2 plus 0.2 Vx. What are the outgoing currents here? These two are going to be same. So it is same, it is going to be outgoing currents is I4 plus I3. Now what is I4? Current is flowing from V4 to V1. So V4 minus V1 divided by R4. I3 is V4 minus V5 divided by R3. I2 is nothing but V2 minus V3 divided by R2. So here this is 0.2 Vx. So how to find out your Vx? Apply your KVL here. V1 plus Vx minus V2 is equal to 0. So here Vx is equal to V2 minus V1. So if I substitute, I'll get the third equation. So this is your fourth equation. So solving equation 1, 2, 3 and 4, we can find out the voltages V1, V2, V3 and V4. So find the voltages V1, V2, V3, V4 in the circuit shown in figure below. So now we are going to take this circuit. This is your circuit here. First we are going to assume that your V1 supernode is V1 plus 12 volts is equal to 0. So V1 is equal to minus 12 volts. Next supernode is V3 and this is your V4. So this voltage is going to be your V4 voltage there. So when I am going to see a supernode, your incoming current is going to be 0.5 Vx and I2. So 0.5 Vx plus I2 is the incoming current. Outgoing current is going to be, so since this is a supernode, your V3 and V4 are going to be your same nodes there. So here it is going to be I4 plus I3. So what is your I4? I4 is nothing but V4 minus V1 divided by 2.5. So in this case it is V4 minus V5 divided by 1, that is V4. What is Vx? Vx is nothing but V1 plus Vx minus V2. So here Vx is V2 minus V1. So substitute in the above equation, you will be getting your equation 2. Next is coming to your third equation. Third equation is here applying KCL at your node 2. Node 2 is nothing but I2. So 14 is equivalent to your I2 plus I5. So here V2 minus V3. So V2 minus V3 divided by 2. So this is your 2 ohms there, plus 0.5 into your Vx. Vx is nothing but V2 plus 12. V1 is nothing but minus 12 volts. So substitute here V2 plus 12 is equivalent to your V4. V4 is nothing but V4 by 1. So V4 by 1 plus V4 plus 12, V1 by 2.5. So if we substitute it, we will be getting this equation. That is your equation 2. So next is your V3, your equation V3 minus 1.24. So here in this case V3 minus V4 is equivalent to 0.2 Vy. What is Vy? Vy is nothing but this equation. It is V4 minus Vy minus V1. So it is V4 minus V1. So this equation will be getting equation as V3 minus 1.2 V4 is equivalent to 2.4. So for node V2, if I simplify it, these 4 equations, I will be getting these equations to be V2 is minus 4 volts, V3 is 0 volts, V4 is minus 2, V1 is minus 12 volts there. So here we are going to refer the figure below and find the current in the 12 ohm resistor. So on the voltage across the current source. So we know that between the two nodes we are going to have your voltages, that is your 25 volts. So in this case it is going to be a super node. So what we are going to do is, first we are going to do your current shifting theorem. So in the current shifting theorem, from X to Y I am going to connect a current source. From this Y, X to this Y I am going to connect the same current source. Instead of straight away flowing, I am going to connect from here to here and from here to here. So in that case this 2 will be reduced. So this is not super node, this is going to be your simple voltage analysis. So you are going to have your current to be reduced. This is your current source in parallel with your resistance converted to your voltage source. So voltage source is, this is your arrow mark. So this should be a plus and this should be minus. So this is your plus, this is your minus there. So 100 volts, 20 ohms. So similarly here it is going to be 5 minus 3b. These are two are current sources, both are in opposite direction. So I will have it as addition is 5 minus 3b there. Then you are going to have your resistance, your voltage source here. So if I redraw the circuit, this is going to be the circuit there. So here I1. So I1 is nothing but this is the current direction. You are going to have your I1 to be like this. So I1 is nothing but, so plus 2 minus is going to be, from here if I start, it is your minus 25. So minus 2 plus is going to be plus 100 divided by total resistance is going to be 25. So we write it as I1 is equal to 100 minus 25 divided by 25, that is 3 amps. 75 divided by 25 is 3 amps. So we know that VA, the voltage VA is going to be your voltage here in this case across a 5 ohm resistor. The current through this 5 ohm is nothing but 3 amps. So VA is nothing but 15 volts. Now we are going to apply the KCL at your node X. So when I am going to apply the KCL at node X, the current that is going to come here is going to be your I1 current. The current that is going to come here is going to be IB. So incoming current to this node is I1 plus IB is equivalent to outgoing current is 5. So here in this case IB is equivalent to 5 minus I1. I1 we already found out, that is 3. So 5 minus 3 is 2 amps. So next is I2. So to find out your I2, we are going to have your current to be your I2 is equivalent to 5 minus 3B. That means that your I2 is going to be the outgoing current like this. So I2, the incoming current is 5 minus 3B. So I2 is equal to 5 minus 3B. So 5 minus 3 into IB current. IB current is 2. So it is minus 1 amp. So here in this case, if I apply my KVL, it is going to be minus V2 plus 12I2 plus 2VA. So here in this case, V2 voltage plus 12I2, the current that is going to flow here is going to be I2, 12I2 minus 2VA, so minus 3IV here. So when I'm going to apply this KVL equation, this is your equation what I'm going to get. V2 is equal to 2VA plus 12I2. So if I substitute it, I'm going to get your 18 volts to be at the output there. So here this is a simplified circuit. We are going to get the output V2. So here minus 100 plus 20I1. So this is going to be a minus V2. The current that is going to flow through is going to be a plus VYX. So your VYX is nothing but 100 minus 20I plus V2, that is 58 volts.